Hello to all, my name is Shaaktam, and today we'll be discussing the Challenger questions from the book All in One for Grade 10 Probability. Okay, so let us start with the first question, which tells us the fact that there is a certain event, and the odds against that certain event is 3 is to 8. What we have to find is the probability of the occurrence of that event. Now, this may look like a very easy question, but the problem is the odds in or the odds against. These kind of questions are very frequented in major Olympiads, and there's a lot of confusion, there's a lot of doubt regarding these questions. Today, we'll nip that all in the bud. Now, it's not just 1 minus 3 by 8 or anything in that fashion we have to do in this question, rather, something very much more complicated. But when you'll see how simple it actually is, you'll not find the complexity. So when they say odds in favor of an event, that doesn't mean it's just so we can straight away say there'll be 3 by 8. This ratio, what I mean to say, is if they're telling in this question, is this odd against? So it's not just the probability that that event will not happen by total, the outcomes in which that event will not happen by total outcomes. No. But since this is odds against, now let's name this event E. So odds against event E will be the probability that E will not happen, means the negation of the probability of the occurrence of the event divided by the probability of the occurrence of the event. So it's a ratio of probabilities and not a probability in itself. That's a simple thing we need to remember to tackle any question related to this. Similarly, if the question were to ask us odds in favor of said event E, it would be the reciprocal of this, which means we would get PE by PE dash. And I'm sure all of you must be privy to the fact that PE dash is nothing but 1 minus PE. So this is a common fact. I don't need to elucidate or elaborate much on this because it's similar to a gospel truth. You have become used to it. If you're not, please know that these kind of formulae are the ones which are frequented in examination. In fact, this kind of formula will also be found in an examination like NCRT board examination. So please remember that you need to sing this like a canary to yourself. That is the preparation required to ace an examination, to get the ambition, to pursue the ambition you want. Coming back to the question. The question says that the odds against a certain event is 3 is to 8. Now, as I said, we are not aware of what the total outcomes are. But we know that this is a ratio of the probabilities. How about we take the total outcomes as X? If we know that the total outcome is X, then the probability of, now let's make this again, instead of E, let's make it A. Let's assume that this event is A. That means since I assume the total number of outcomes as X, PA will be 3 by X. What is PA then? PA dash, sorry. Because they're saying odds against the event is 3 is to 8. That means PA dash will be in the numerator. And that means PA will be 8 by X. Where X, as I said twice, is the number of outcomes. Now the question is basically linchpinned on this fact and the equation I wrote, that PE dash is 1 minus PE. So similarly, we can also write that PA dash is 1 minus PA. PA dash, I repeat, is 1 minus PA, which means that 3 by x plus 8 by x, just bring this to the side of the equation, is equal to 1. And now we can get x easily. It will be 11 by x is equal to 1, meaning x is equal to 11. Okay. Now it's easy. What the question is asking now is again something which is confusing. They talked about the odds against the event being 3:8, but now they want the odds that the probability of the occurrence of this event, meaning they want PA, not PA dash, PA. Simple. And PA now you can get easily. The answer to this will be 8 divided by 11. Now, it may be the case in some books it's 3 by 11, but as we have shown you by logic, it should be 8 by 11. So please correct this if there's an error in your book, of course. Moving on now, class, to the second question we have at hand. The second question shows a figure, and that figure is a disk. Okay? The given figure shows a disk on which a player sends an arrow twice. For the sake of the class, I'll be drawing this disk. It may not be, of course, to scale, but please bear with me. So that there are 6 sectors labeled in the fashion they are given. Okay. So let's draw them. That's 1, 2, 3, 4, 5, and 6. Fair enough. They are numbered in what fashion? 1, 2, 3, 4, 5, 6. And there's just a representation of the arrow. It's not indicating on 4, of course. That is logic. It's just a representation of what is the case. Now, what is the question asking? The given figure shows a disk on which a player spins an arrow twice, such that the fraction x by y is formed. So we are forming a fraction x by y when we spin this circle or disk in such a way that x is the number on which the sector stops in the first spin. So first spin, sector number is x. Similarly, y is the second spin's sector number. So on the first one, let's say if I reach 1, and on the second spin I reach 6. So my fraction will be 1 by 6. Fair enough. Now we have understood the language of the question, but now let's get into what it is asking of us. It's asking that in each, now it's telling another information that in each spin, reaching a certain sector with a certain number has equal probability of selection. There's no bias or anything. This is a system with no bias. This means it's equal probability of reaching any of the sectors 1, 2, 3, 4, 5, 6. And since they are 6 in number, it's equal probability. So 1 by 6, 1 by 6, 1 by 6, 1 by 6, 1 by 6 is basically what they mean. It's simple. It's just saying that there's no bias in the system. Then the probability that the fraction x by y, the probability that the fraction x by y is greater than or equal to 1. That is basically what the question is asking is the probability. Okay. Now, what we can make of this question, since they're asking a probability, is first the total number of outcomes. Can't we say that since we have to take two numbers, two random numbers, then we have to write 6 square in the denominator form to show that that's the total number of outcomes. So our denominator, I repeat, for the question's answer will be 6 square, 36. So we can keep that aside, but just keep that in mind. That the denominator will be 36. And now we look at the favorable outcomes. Now, let us say that the probability the question is asking us for is PE. Again, PE. It's PE such that x by y is greater than or equal to 1. This means that the negation of E or the complement of E will be the probability that x by y is lesser than 1. Because it can either be greater than 1, lesser than 1, or equal to 1. The probability that x by y is greater than or equal to 1 is PE. That means the probability that x by y is lesser than 1 will have to be PE dash. That is what the question is asking. Fair enough. Now we'll just take different denominators and different numerators and see the fractions, and then we'll get to know our answer. So let us do that. Fair enough. When I get 1 on the first step, there has to be some number, theta, let's say, such that this has to be lesser than 1. Now, I'll discuss only the negation for now. And again, use of the same formula that PE dash is 1 minus PE. Which means, whatever probability I will get for PE dash, for the answer, I'll just have to do 1 minus that. Fair. Now, I have 2, 3, 4, 5, and 6. But I have to manage that 1 by theta has to be lesser than 1. It can't be 1, of course. But it can be everything except 1. It can be 2, it can be 3, it can be 4, it can be 5, it can be 6. So for this case, we got 2, 3, 4, 5, 6, a total of 5 outcomes. Next is 2 by theta. Let's just keep taking theta for the sake of the class. So what is asking? It's saying rather that 2 by theta is lesser than 1. So you can't put 1 because 2 by 1 will be 2. You can't put 2 because 2 by 2 will be 1. But you can put 3, 4, 5, and 6. That means 3, 4, 5, and 6 are another 4 outcomes. Similarly, we take 3 by theta. 3 by theta has to be lesser than 1. And that will get us, we cannot put 1, 2, or 3. But we can put 4, 5, and 6. And that will get us 3 outcomes. So similarly, now you can see a pattern. For 1 by theta, we got 5 outcomes. 2 by theta, 4 outcomes. 3 by theta, 3 outcomes. So 4 by theta, you will have 2 outcomes. And 5 by theta, you will have 1 outcome. You can figure it out yourself. And 6 will, of course, have no outcome. Because everything will be either greater than or equal to 1. So first, we'll add these. The probability that the fraction is lesser than 1. Fair. As I told you at the initiation of the discussion of this question we had, the total number will be 36. The total number of outcomes will be 36. And here we'll get 5 plus 4 plus 3 plus 2 plus 1. 1 plus, 5 plus 4 plus 3 plus 2 plus 1. That will get us 15 by 36. But keep in mind that this is not the answer you should simplify and put in the question. So now I think all of us are getting educated on how tricky the examiners will make these questions. So that for the most obvious of reasons, which we label as quote unquote silly mistakes, we lose our marks. And you should accept this concept of silly mistakes is really obsolete and obscene, if I were to consider. Right? Accept that's a mistake you made. Be accommodative. Back to the question. Now, 15 by 36. If I simplify that, I'll get 5 by 12. Hence, I get 5 by 12 as the probability of x by y being lesser than 1. But the question is asking me whether x by y is greater than or equal to 1. So what do? Simple. I'll do 1 minus 5 by 12, which will get me the answer as 7 by 12. So this ends the discussion for question number 2 of the calendar section. All in one book, class 10 probability. Let's move now to the third question. Now, let me read the language of the third question. A graph is shown below, and the intersection points of two lines are said to be the integer points. So I'll just draw the figure. They have drawn a graph kind of structure. A typical structure which you'll see on the graph paper. Okay, so they have drawn this structure such that the intersection points of two lines are said to be the integer points. Now they have made for us, of course. So let's first mark these 1, 2, 3, 4, 1, 2, 3, 4, 5. They have made for us a rectangle. They have highlighted for us a rectangle formed by points A, B, C, and D, which are as follows. So they have made till 5 and 6. Let's also make till 5 and 6. 5 and 6. Fair enough. So point D, according to the question, is 1, 4. 1, 4 means it lies somewhere here. So there's where D is. Similarly, we have point C, we have point C, 5, 4. We have point B, which is 5, 1. And then we have point A. We have point A, which is 1, 1. So for the ease of the question, let's highlight the rectangle. Now they've taken a point 4, 3. 4, 3 will be over here. And labeled this point as E. What they're asking is the probability of E with respect to integer points in the rectangle ABC. It may seem confusing, but basically they ask of us that how many points are in the vicinity and what's the probability that if I list all the coordinates of these points and let's say list them, make chits, put them in a bag and pick out randomly, what's the probability that I get point E? So it's not that hard. We can easily get that this distance is 5 and this distance is 4. It's basically in the vicinity of the rectangle. So total number of outcome is 5 into 4. Because here we have 5, there we have 4. So we can, when we list them, we'll get a total of 5 into 4 or 20 points. And they're asking the probability of selecting E. That will easily be 1 by 5 into 4, which will be 1 by 20. So a childish question, but with manipulative language. I repeat, a childish question but with manipulative language. Now, next question to discuss. There are two die numbered. One numbers are 1, 2, 3, 4, 5, 6. A normal die, which you will find in the routine game like Ludo, Business, Monopoly, etc. But another die, which has 1, 1, 2, 2, 3, 3. 1, 1, 2, 2, and 3, 3. They are thrown such that the sum of the numbers is noted. So you throw both of them, you see the number landing, you add the sum, you add the numbers, you note the sum. Then the probability of getting an even sum is. Now, a straight away answer I can tell. The sum can either be even or odd. Because these are 1, 1, 2, 2, 3, 3. Whatever be the case, the sum will have to be even or odd. Of course, if it's not an additive, if it's an additive inverse, and if it's a number and it's additive inverse, then it's different. But here we have distinct natural numbers. And thus the sum can be either even or odd. So to secure ourselves from our confusion, since there's equal probability, there are two events. So PA is 1 minus PA dash, such that PA and PA dash are equal. So straight away I can say that the sum will be 1 by 2. Because it can be either even or odd. So it can either be even or odd. That is what the students will think. Right? That is what the students will think. And this is the wrong thinking process. Okay? So now let's note down the sum straight. They're asking for even. So if we are taking an odd number, we only when odd plus odd will be even. And if we are taking even number, only even plus even will be odd. So 1 comma 1 is 1. Then we have 1 comma, okay. So we have 1 comma 1, 1 comma the first 3, and 1 comma the second 3. Then I take this other one, 2 comma the first 2, 2 comma the second, 3 comma the first one, and 3 comma the first one, 3 comma 3, and 3 comma 3. 4 comma 2, 4 comma 2, 5 comma 1, 5 comma 1, 3 comma 3, 3 comma 3, 6 comma 2, 6 comma 2. Okay. Now you're selecting them. The total number will be 36 only. You can form 36 pairs. 6 raised to 2, 36 pairs. Now 1, 2, 3. So 3. So then these two pairs plus 2. 1, 2, 3, 4. Plus 4. Plus 2 again. Plus 4 again and then plus 2. Plus 4 plus 2. 36. 4, 4, 8. 10, 12. 17 by 36. Are we missing something? Let's check it out. 3 comma 1, 3 comma 1, 3 comma 3, 3 comma 3. 1, 5 comma 1, 1, 3, 5 comma. So we get 1 comma 1. Aha. We missed another 1 comma 1 because you can form another pair. Right. So now you can see I'm misleading you because at the end of the day it's getting you another 1. So 4 plus 2, which is 18 by 36, is equal to 1 by 2. By the way, the easy one, again, I'm back to my theory. It's just 1 by 2. You can just mark it if it's an even sum or an odd sum. They've asked me something like that. Then you can mark it as 1 by 2. I'll be keeping 20 to the fifth question. We'll be discussing the next 5 questions in the next video. Let's do the fifth question first. It involves cards bearing numbers 1 to 1000, such that we randomly pick one card from the box and randomly pick one card and put it in a box. Each player selects one card at random, and that card is not replaced. So there's no doubt of replacement, non-replacement here. They straight away told it's not replaced. The player only win the prize if the selected card has a perfect square number greater than 500. Okay. The probability that the first player wins this. Obviously, there'll be 1000. Now, what is the first square number which is perfect square number which is greater than 500? First of all, is 500 itself a perfect square number? No. But the closest is 22 square. 22 square is 484. We don't have to consider 22 square. They said greater than 500. The next one is 23 square, which is 529. Then 24 square as 576. so on and so forth. We'll get 31 square 961. But 32 square will be 1024. So we don't have to consider it. So you have to consider only from 20 square to 31 square. And the number that will be 23, 23, 24, 25, 26, 27, 28, 29, 30, 31. So we'll get 9 by 1000, 0.009. Fine. You got it. And then similarly, what they're asking is the probability of the second player win the prize if the first has already won is. Meaning what you did, you took out a square number. I don't know which square number that is. But now we have 999 cards first. In that case, we had 9 square numbers. And now we'll have 8 square numbers. 8 by 999. I think I do have time, so I may be able to discuss the questions. Let's see. So you got the first one as 0.009, 8 by 99. These are very easy questions. The next one is childish 6th grade kind of question which you should be able to solve in a fraction of a second. A box contains 54 marbles and each of them is either blue, green or white. Probability of selecting blue marble at random is 1 by 3. Probability of selecting green marble is 4 by 9. And then find the probability of white marbles find the number of white marbles in the box. Now, what's the probability of selecting white marbles? We can easily get 1 minus 1 by 3 plus 4 by 9. Why? The sum will indicate the probability that you will not get white. So to get white, you'll have to do 1 minus that. And that'll get you 1 by 3 is 3 by 9, 3 by 9 plus 4 by 9, 7 by 9. So it'll get you 2 by 9. And then 2 by 9 into 54, you'll get a total of 12 white marbles. Next one is a tad over the top. Next two. Next three rather, let's say. But they can be answered. We have a helicopter. This 10 cm, that's 10 cm. Such that they have labeled 4 regions. So we have a helicopter crashed in this square. Then what's the probability of landing in the flowerish region I just drew for you? That's the question. It's very easy. You can actually see 4 semicircles. This semicircle, this semicircle, this semicircle, and this semicircle. Now, they are asking the probability of landing in these regions. Well, let's look at it. First of all, the total area will be 100 centimeters square. Fair. Now, the area of the semicircles. You can see 4 semicircles with diameter 10 centimeter, which means that radius 5 centimeter. So 4 semicircles, radius 5 centimeter. That's what we know. But if you add up all their areas, you'll see that you've counted each quarter twice. For example, this will cover these two. This will cover this repeat. Let's mark them 1, 2, 3, 4. 1, 2, 3, 4. The first semicircle, there are no repeats for now. The second semicircle, you have repeated 2. Third semicircle repeated 4. Fourth semicircle repeated 3. And then vice versa. So you can see that there's a repetition, clear repetition. 1 repeated, 2 repeat, 3 repeat, 4 repeat. Now, let the area of landing in the semicircle be AS. You can see that the square will be everything. But the area of the semicircles or these shapes rather, let's take S as shapes, AS as the area of shapes, will be the area of semicircles minus the area of the square. So that's a given. Area of the semicircle, how you can do? Easily 4 into pi into 5 square minus 10 square. So 4 into 5 square, 4 into 5 square will be 100. So 100 pi minus 100. So this will be your answer. So you can do 5 minus 1. 20 by 7 minus 1. Just a minute. I think I'm missing something. There are 4 semicircles. 4 into 5 square. This is rather peculiar. Pi minus 1. Aha. We saw 4 semicircles, but that means we saw 2 circles of radius 5. So it will be 2 into pi 5 square. It will be 50 pi minus 100. 50 pi minus 100. So you'll get pi by 2 minus 1 will be 11 by 7 minus 1. 4 by 7, and 4 by 7 is approximately 0.57. So that's how you will get. You'll see that the area of landing will be the area of all the semicircles you can form minus the area of the square. And then the total outcomes will be, of course, the total area. The two next questions are really difficult. They'll require a lot of intelligence. But due to paucity of time, I won't be able to discuss them in this video. I'll be making a new video discussing these two questions because these are types which you'll find in the international Olympiads. Thank you for watching this video. Right.